Hi students, this is Alex here. In this video, we are going to find the Fourier series for the given function f of x, which is x minus x square in minus pi comma pi, and we are also going to deduce this series. Now, I am going to take f of x, which is x minus x square. I am going to find whether it is even function or odd function. So for that, x is replaced as minus x. So wherever x is there, we replace it with minus x. But this value is minus x and there is a minus sign. Minus x whole square is x square again. So we are getting totally a different function than f of x. So this is not equal to f of x. Therefore, we can say f of x is neither even nor odd. So now we are going to find a naught. A naught is by formula 1 by pi integral minus pi to pi f of x dx. So this is 1 by pi integral minus pi to pi f of x is x minus x square into dx. Now we are going to integrate this. We have 1 by pi. Integration of x is x square by 2 minus x square is x cube by 3 and limit is from minus pi to pi. Now we substitute the upper limit pi for x, so pi square by 2 minus, and this is pi cube by 3 minus, when I take lower limit, it is minus of pi square by 2 minus minus pi whole cube by 3. Now we simplify further. This is 1 by pi. First term is pi square by 2. Second term is minus pi cube by 3. And this when I square it will become positive, but outside there is a minus sign. So it is minus pi square by 2. Then this is minus. Already there is a minus, so plus, but outside there is a minus, so it is totally minus. So minus pi cube by 3. So here we see pi square by 2 minus pi square by 2 we can cancel. Then we can add the like terms. So 1 by pi into minus 2 pi cube by 3. We can cancel this. So it is square. So from this, the value of a naught is minus 2 pi square by 3. So we got the value of a naught. In the same way, we are going to find an. So the formula for an is an equal to 1 by pi integral minus pi to pi f of x into cos nx dx, and this is 1 by pi integral minus pi to pi x minus x square into cos nx dx. Now we are going to do Bernoulli's formula. So u is x minus x square and v is cos nx. From this we are going to find u dash, which is 1 minus 2x, u double dash, which is minus 2, u triple dash, which is 0. From this v1 is integration of cos nx is sin nx by n, and v2 is integration is minus cos nx by n square, and v3 is minus sin nx by n cube. Now coming to an, we have 1 by pi outside. We are going to use the Bernoulli's formula u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus dot dot dot. Now we take u v1 here. So 1 by pi, u is x minus x square into v1 is sin nx by n. So here it is sin nx by n minus u dash, which is 1 minus 2x, and v2 is minus cos nx by n square. So I make this as plus and put cos nx by n square and plus u double dash. U double dash is minus 2 and v3 we have minus, so I make this as plus sine n pi by n cube. So we have to substitute the limit minus pi to plus pi. When I use a limit, wherever sine nx, this becomes 0. When I put ns, sorry, this is nx. So wherever sine nx is there, when I use the limit pi, this becomes 0. So straight away, I put the upper limit, first term is 0, second term is 1 minus 2 pi into cos n pi is minus 1 whole power n by n square. Then lower limit, once again, first two terms are 0 and this will become, when I put minus pi here, it will become 1 plus 2 pi into minus 1 whole power n by n square. And here we can take 1 by pi and minus 1 whole power n by n square common. So 1 minus 2 pi and minus of this. So minus 1 minus 2 pi. So we can cancel minus 1 plus 1. So finally this is 1 by pi minus 1 whole power n by n square, and this is minus 4 pi. Now pi we can cancel and it is minus 4 into minus 1 whole power n by n square. But this minus is actually minus 1 and already we have minus 1 whole power n. So it is minus 1 power n. So when I combine, it will become power n plus 1. So an value finally it is 4 into minus 1 whole power n plus 1 by n square. Now we have to find bn in the similar way. So bn by formula, bn equal to 1 by pi integral minus pi to pi f of x into sine nx dx, and this is 1 by pi integral minus pi to pi x minus x square into sine nx dx. We are going to take, by Bernoulli's formula, u is x minus x square and v is sine nx. So from this, u1 is 1 minus 2x. Actually it is u dash. So u dash is 1 minus 2x. U double dash is minus 2. U triple dash is 0. v1 is minus cos nx by n. When I integrate sine, it becomes minus cos. Then v2 is minus sine nx by n square, and v3 is cos nx by n cube. Now bn value is 1 by pi, and we are going to write the Bernoulli's formula, uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus dot dot dot. Now this becomes 1 by pi u, which is x minus x square, v1 is minus cos nx by n, then plus, minus u dash, which is 1 minus 2x into v2, which is minus sine nx by n square, and third term u double dash, which is minus 2 into v3 cos nx by n cube, and minus pi to pi. We are going to use the limit. When I place the upper limit, first term is pi minus pi square into minus, then minus 1 whole power n, because cos n pi is minus 1 whole power n by n. Similarly, second term no need to write because sine nx will become 0 when I put x as pi. And last term minus 2, then minus 1 whole power n by n cube, because cos n pi is minus 1 whole power n. Minus, when I put the lower limit minus pi, it is minus pi square, because when I square it will become pi square and there is outside minus. And similarly, this is cos n into minus pi, but cos of n into minus pi is also cos n pi. So this is also minus 1 whole power n. So minus 1 whole power n by n. And second term is 0. Last term is minus 2 into minus 1 whole power n by n cube. Now this is 1 by pi, and we can take minus 1 whole power n common throughout. So there is a minus sign which is multiplied here. So minus pi plus pi square by n. Then when this minus 1 power n is out, we get only minus 2 by n cube. And this minus, if I multiply inside with this, it will become positive, but still there is a negative term, minus pi square by n. Then again, this minus when taken inside, this becomes plus 2 by n cube. So totally we can cancel these two, and here common denominator pi square minus pi square we can cancel. So totally we get this as 1 by pi minus 1 whole power n minus 2 by n. Actually minus 2 pi. So pi we can cancel. And this minus sign along with this minus 1 combined together as minus 1 whole power n plus 1, then whole divided by n. So this is our Bn. Bn is 2 into minus 1 whole power n plus 1 by n. Now we are going to write the Fourier series expansion f of x by formula. It is a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. So here f of x is a0 by 2. A0 is minus 2 pi square by 3. So minus 2 pi square by 3, and there is a by 2, so we put in the denominator, plus summation n is equal to 1 to infinity an. So an is 4 into minus 1 whole power n plus 1 by n square. So this is 4 into minus 1 whole power n plus 1 by n square into cos nx plus summation n is equal to 1 to infinity bn. Bn we got here 2 into minus 1 whole power n plus 1. So 2 into minus 1 whole power n plus 1 by n sin nx. And here if we want, we can take the constants out of the summation and we can cancel these two. So minus pi square by 3 plus 4 summation n is equal to 1 to infinity minus 1 whole power n plus 1 by n square cos nx plus 2 summation n is equal to 1 to infinity minus 1 whole power n plus 1 by n sin nx. So we got the Fourier series expansion. Now in the question they have given to deduce a series, and for this we have to take a value of x. Let's take x as 0. So here let's take x as 0. So now f of 0 will be, f of x is x minus x square. So 0 minus 0 square, which is 0. So this becomes f of 0 equal to minus pi square by 3 plus 4 summation n is equal to 1 to infinity minus 1 whole power n plus 1 by n square. Cos 0 is 1 and sin 0 is 0. So we have only this much left. And this term we can take to the other side, because this is 0 plus pi square by 3 equal to this 4 we can take to the denominator here, and this summation I am going to expand. When n is 1 we get power 2 by 1 square. When n is 2, minus 1 whole power 3 by 2 square. When n is 3, because already power n plus 1, so when I put 3 it becomes 4 by 3 square. Then minus 1 whole power When n is 4, it is power 5 by 4 square plus dot dot dot. And here this is pi square by 12 equal to, this is 1 by 1 square, then minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus dot dot dot. Thus, we got the required proof. So let's rewrite this. The question they have given the summation first, 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus dot dot dot, which is pi square by 12. So hence we got the proof.